Alright guys, welcome to section 9.2. Today we're going to talk about arithmetic sequences. So this is the second section of chapter 9, and in 9.1 we looked at specific patterns of sequences. But there's really two sequences we can look at. One is called arithmetic and the other is geometric. Arithmetic sequences talk about having a common difference between two terms, and we're going to look at that today. So your essential understanding out of section 9.2, an arithmetic sequence, in an arithmetic sequence, the difference between consecutive terms is constant, meaning it's the same. So when we look at a term and one right after the other, the difference is always going to be the same all the way through, and we'll look at that today. A constant is just a number, okay? And you can also note that any missing term can be found if you know the following information. If you know the first term and a common term, you can find the equation or the rule for that sequence. And secondly, if you know the first term and if you know the common difference, you can also write the equation. So we're going to look at four examples in talking about arithmetic sequences, but let's spend a little more time on what the definition of an arithmetic sequence is. Okay, an arithmetic sequence, it's a sequence, okay, so it's a list of numbers, but there's something special about those list of numbers. So an arithmetic sequence with a starting value of A and a common difference D is a sequence of the form A, comma, A plus D, A plus 2D, etc., and it keeps going on. A plus 2D plus A plus 3D. So you may think, well, what does that mean? We're going to look at another example here in a minute. But there's two ways we can write arithmetic sequences. You can do it recursively or explicitly, and we talked about that in section 1. Recursively means we use the previous term to get the next term. How can we use the term before it to get the next term? So this is how we write the rule. Again, you start with the first term, and here's our equation. Whatever term we want is equal to the previous term plus the common difference D, and here n has to be greater than 1. For explicit, okay, the explicit definition or the explicit formula, we have whatever term we want is equal to A plus the quantity n minus 1 times the difference, the common difference, and n can be greater than or equal to 1 here. Okay, so those are our two rules. We have arithmetic, we have recursive and explicit. So that's what we're going to look at today, writing equations that are recursive and explicit for arithmetic sequences. So let's look at an example of a sequence that's arithmetic. Problem number 1, determine if each sequence is arithmetic. Okay, so now we have to look at and think, well, is the difference between consecutive terms constant? Is it the same? So, in this first example, we have a sequence that's 2, 3, 5, and 8. Okay? So I look at what's the difference between the two numbers? Well, between 2 and 3, the difference is 1. Between 3 and 5, the difference is 2. And between 5 and 8, the difference is 3. Okay? And we're not subtracting here with the difference. We want to know really how far apart are the two numbers. How many numbers are between 3 and 5? 2. How many numbers between 5 and 8? Okay, that's the idea. So when you see that plus 1, plus 2, plus 3, we're not subtracting. You could. 3 minus 2 is 1, 5 minus 3 is 2, and 8 minus 5 is 3. Okay, so there's really kind of two ways to look at that. So it's plus 1, plus 2, plus 3. So don't be confused and say, well, why isn't it subtraction here? Okay, you can add 1 each time, 1 difference, 2 difference, 3. Okay, or you can actually subtract. The last term minus the previous term is 8 minus 5 is 3, 5 minus 3 is 2, and 3 minus 2 is 1. So the common difference here is not the same. If it was the same, we would have the same number at each of those 3 spots. So this is a sequence that is not arithmetic because the common difference is not the same. Now, the second example, 127, 140, 153, 166. Okay, and we see the comma dot, dot, dot. Again, that means a infinite sequence. That pattern will continue. So if I start on the end, the last number, 166 minus 153, that's 13. And it looks like I forgot the 1 there. Okay, 153 minus 140 is 13. 140 minus 127 is 13. So each of these common differences is the same number. Okay, it's common. The differences are all the same. That is an arithmetic sequence since the common difference is the same, and in this case it's 13. Not an arithmetic sequence. This is an arithmetic sequence. Okay, problem number 2. Let's write an explicit and a recursive formula for the following sequence. So we're doing two things in this slide. Okay, our sequence is 0, 6, 12, 18, and 24, a finite sequence. There's no comma, dot, dot, dot. So this is finite sequence. So let's start with recursive formula. Number 1, you identify the first term. Okay, so I look at my sequence. My first term is 0, and I write that. The first term is 0. Now, the second part of this, you have to think, how can I get the next term by using the previous term? So how do I get 6 when I have 0? Well, I could add 6. You can't multiply by 6, you'd get 0 here. So if I add 6 here, great, that works. To get 12, I add 6 to 12. To get 18, I add 6 to 12. Okay, so you can see that the common difference here is going to be 6. So recursively, to get the next term, I take the previous term and add 6. So that's my rule, that's my equation. Okay, so remember with recursive, you got to identify the first term, and then secondly, how do I get the next term from the previous term? That's what you have to ask. And when we write the recursive formula, you need to write the first term, and you need to write the rule, the equation, the definition. Okay. Now, an explicit formula, that's just using the equation in terms of n. We're not using the previous term. So we can just plug in n and get our value. So explicitly, our first term is 0 plus n minus 1. In this case, it's times 6. I know when we talk about arithmetic, you think of addition, but in this case, it's easier to rewrite the rule with times 6 here. So there's our explicit rule or formula. And you don't need the 0 technically. I wrote there, so I simplified and said a sub n equals 6 times the quantity n minus 1. So if I wanted the third term, okay, a sub 3 equals 6 times the quantity of 3 minus 1. Well, 3 minus 1 is 2. 6 times 2 is 12. So that works. I can check real quickly to see if my rule works. So that's recursive and explicit formulas or definitions. I keep saying formulas and definitions because in different texts they may call it a formula or a definition or maybe even a rule. So you need to be able to interchange the three. Okay, so recursive rule, recursive formula, recursive definition for that sequence, and same thing with explicit. All right, in our third problem, we're going to look at finding the 43rd term of this sequence. Now, if we're trying to find the 43rd term, we really have two options. You have recursive, you could write a rule for that, or you could use explicit. Okay? Now, if I need the 43rd term, I'm not going to use recursive because I would need the 42nd term in order to find the 43rd term, and that's just too long. Too much work. Okay, so we're going to actually define this explicitly. And here we can't really see it, but that says a sub n. Looks like it got caught on the board a little bit. So we have a sub n equals a sub 1 plus n minus the quantity n minus 1 times d. So there's the standard definition for this sequence. Now, I have to know what my common difference is and what my first term is. First term is 1.3. I'm checking to see if the common difference is the same. If it is, we know this sequence is arithmetic, and it is. 1.4 minus 1.3 is a tenth. 1.5 minus 1.4 is a tenth. 1.6 minus 1.5 is also a tenth. So there's my common difference. So I know that the d value is going to be 0.1. So I substitute d in, and I also substitute 1.3 in, my first term and my common difference. But I want the 43rd term. So a sub 43, n is 43, the 43rd term, the nth term. So 43 now equals 1.3. So wherever we see n, we're going to plug in 43. And we do. So 42 times a tenth plus a third, and that equals 5.5. Okay? And we've got one more example to finish up here with arithmetic sequences. Find the missing term. Okay. In this case, we're going to use the arithmetic mean. When you find the missing term, 1 space, blank, and 2. We're missing the value in between, in the middle of these two, somewhere. Okay. Now, to do that, we're going to take arithmetic mean, which is adding your two terms up and dividing by 2. You might say, well, that sounds like average. It is. It's an average. So negative 6 plus 2 divided by 2 equals negative 2. So that missing term is negative 2. Okay? So that is arithmetic sequences. Okay? Arithmetic sequences have a common difference that's all the same. You can add a number to a term to get the next term. Later on, we're going to talk about geometric sequences, where it's no longer a common ratio, but or common difference. It's a common ratio, and we don't add to get to the next term. We actually multiply. So we'll see you for the next lecture on 9.3. Thanks.